Section 3.2, two variable equations. Okay, so let's talk about that. First of all, I think the best thing to do here is just to jump straight into an example, kind of to see where this is going. When we see a two variable equation, an equation that has x and y in it, what's going on there is that we're tying together an x value with a y value. Okay, in other words, we're looking for the pair of numbers that when you plug in the x value and the y value, you end up with a true equation. Okay, so let's start off with these types of questions where I give you one of the values and you find the other one, right? So negative x plus 2y equals 4. That is a two variable equation. We have two variable terms on the left side, we have a constant term on the right side, but notice the difference in the variable terms. One's in terms of x and one is in terms of y. Okay, that matters, right? So the first question here, if x equals negative 2, then what is y? Okay, well, let's actually go and substitute negative 2 in place of x and see what we get. So negative x plus 2y equals 4. Notice I'm leaving a blank there so I can plug in negative 2 in place of where x was. Notice there's two negatives there now, right? There's the negative on the outside, and then there's a negative that came along with the x value. Okay, so let's simplify that. Negative 2 is a positive 2. So 2 plus 2y is equal to 4. I'm going to solve the equation for y. So, okay, we know how to do that. We subtract 2 from both sides to eliminate that constant term next to the variable term. That will give me 2y equals 4 minus 2 is 2. Then to get rid of the 2 that's multiplied times the y, I'll divide both sides by 2. Y equals 2 divided by 2, which is 1. So when x is negative 2, y is 4. When x is negative 2, y is 4. I'm sorry, y is 1, not 4. I got the 4 from up here. Okay, so if you plug in negative 2 for x, the result is y is 1. You can actually see this play out. Let's plug those numbers in and see if they actually do what I said they're going to do. If you plug in negative 2 for x and you plug in 1 for y, I should get a true equation. So negative 2 is a positive 2 plus 2 times 1 is 2 equals 4. 2 plus 2 is 4. It turns out that 4 equals 4, right? So yeah, negative 2 comma 1 is the ordered pair that results from choosing x to be negative 2. Okay, but I just picked negative 2 for x. What if I picked something else, like y is 3? Okay, well, let's use that same equation. This time, though, instead of having y, I'm going to substitute in 3 in its place. Okay, so instead of 2 times y, I have 2 times 3. 2 times 3 is 6, so I'll simplify that term first. 6. So negative x plus 6 equals 4. Now I'm going to solve for x. So let's get rid of that constant term, negative 6. Subtract 6 from both sides. Negative x equals 4 minus 6 is negative 2. Now, this is an understood negative 1 right here, so I'm going to divide both sides by negative 1. And that will give me x equals positive 2. Okay, so if y is 3, x is positive 2. So that's the ordered pair. Remember, x comes first. X comma y, 2 comma 3. Okay, so an ordered pair, when it comes to equations, that's the pair of numbers that when you plug them in for x and y will give you a true equation. Okay, let's go ahead and plot those points. So negative 2 comma 1. Remember in the last section, negative 2 means left 2 and then up 1. And 2, 3 means right 2 and up 3. Okay, and it turns out that when you're dealing with two variable equations, x and y, and there's nothing squared, right? It's x to the first power and y to the first power. When dealing with those types of equations, what you'll end up with, if you go and plot the points, is if you draw a straight line through those points, any other points that lie on this line any other points that lie on this line will also be a pair of x, y values that work for that equation. Okay, so that's the equation of the line. Okay, all right, let's do another. Here's another equation. 4x minus 8y equals negative 16. Okay, so what happens if x is 0? What is the y value that results? Okay, well, 4 times 0 minus 8y is equal to negative 16. We said x is 0. 4 times 0 is 0. Now you don't actually have to write this part, but that would be 0 minus 8y equals negative 16. The reason why you don't have to worry about that is because 0 minus 8y is negative 8y. So anytime you multiply a term by a 0, you could just scratch it out and ignore it. It's not going to be there anymore. Okay, divide both sides by negative 8. That gives me y equals positive 2. So when x is 0, y is 2. Okay? What about when y is 0? Okay, so we'll rewrite the equation, except this time we'll change out y and substitute in a 0 for y. Like I said, whenever you have a 0 multiplied times a term, you can just scratch that whole term out. This becomes 4 times x equals negative 16. Divide both sides by 4. And that'll give me negative 4. So if y is 0, x is negative 4. Or you could say when x is negative 4, y is 0. Okay, let's talk about those 2 points real quick. So 0, 2, 0 in the middle, then up 2. Negative 4 is 0, so left 1, 2, 3, 4, and then don't go up or down at all. Notice where these 2 points lie. Right? They are on the x and the y axis. Okay? And so let's get to that in just a second. Let me draw my line here. Not very good at drawing lines, but I think you can picture it. Pretend like that's a straighter line. Okay, let's talk about those 2 points. So 0, 2 and negative 4, 0. Those are called intercepts, right? The x-intercept is the point where the graph is touching the x-axis. Okay, so we would say that this point right here is the x-intercept. Of course, that's the point. That's the y-intercept because it touches the y-axis. That would be this point right here, right? That is, I don't want to draw too many arrows that look confusing. This is the y-intercept. Notice the x value is 0 there. Here is the x-intercept because that's the point where the x, or the line touches the x-axis, okay? So the x-intercept and the y-intercept, those are some important points. Again, the x-intercept is the point where the x value is what you're looking for and the y value is 0. The y-intercept is where the x value is 0 and you're looking for the y value, okay? So sometimes people get those backwards, so be careful. If you're asked to find the x-intercept, plug in 0 for y. If you're asked to find the y-intercept, plug in 0 for x. Okay, let's move on. So here, let's talk about equations. So we've had so far all of our equations written out in standard form. That's ax plus by equals c, where a, b, and c are integers, okay, positive and negative whole numbers. Okay, they're not always going to be that way, and standard form is not necessarily the most useful form either. Slope-intercept form is better, depending on what you're trying to do. Okay, slope-intercept form is y equals mx plus b, where m is the slope, and b, at least 0, b, is the y-intercept. Okay, 0b is the y-intercept. M is the slope. Okay, that's extremely useful for the next few types of questions. So the first of these new kind of questions says convert 2x plus 3y equals 12 into slope-intercept form. Okay, that's currently in standard form. Notice there's no fractions. You have the x term, the y term, and then a constant term. So let's put that into slope-intercept form, and then we'll find the y-intercept, the slope, and we'll graph it. So 2x plus 3y equals 12. again, we said we want to find slope-intercept form. I'll write this down right here just to have it in front of us. Okay, I have to get y by itself in order to make that happen. So I have a variable term here with an x, a variable term here with a y. I only want the variable term with a y on the left side. So I'm going to get rid of this term by subtracting 2x from both sides. Now when you subtract, it'll eliminate that term on the left side. It reappears on the other side, right, as a negative. Put the negative 2x before the 12. Okay, don't put 12 minus 2x. You could do that technically, there's nothing wrong with it, but we want it to look like this as close as possible. So notice the variable term x comes before the constant term b. Okay, so we'll do that here. Alright, so we just bring them down, negative 2x and a positive 12. Okay, now divide everything by 3. And here we're going to divide each individual term by 3. Okay, divide each individual term by 3. We end up with y equals negative 2/3 x plus 12 divided by 3 is 4. Okay, so we have y equals negative 2/3 x plus 4. That would represent the slope-intercept form of that same equation. Okay, still, the ordered pairs that work for this equation will also work for this one. It just depends on what you're trying to do, right? Okay, so now, slope-intercept form. We said find the slope. Well, remember, the slope is the number attached to x. In this case, it's negative 2/3. Be careful, don't put negative 2/3 x. The x is not part of the slope, just the number attached to the x. Okay, the y-intercept. The y-intercept is the point 0, 4, the constant term, 0, 4. Okay, so we have 0, 4, and we have negative 2/3. We're going to use that information to graph the line. Okay, so keep in mind, the y-intercept is a point on the graph. We know where that goes. 0, so in the middle, then up 4. And then we have the slope is negative 2/3, which, remember, slope tells you how steep the line is. That'll also tell you how to find other points. Okay, so let's start off with 0, 4. 0, 1, 2, 3, 4. There's my y-intercept. The y-intercept is 0, 4, so I plot that first. Now, from there, use the slope. The slope is negative 2/3. Now, depending on where you put that negative, you can figure out your next point, okay? Let's go with the most natural reading of that, negative 2/3. Remember where those numbers come from if you use the slope formula. The top number represents how much y changes. The bottom number represents how much x is changing. Okay, so this is y's change on top. The bottom is x's change. So in other words, negative 2 means my new y value is going to be down 2. So from, this is important, from the y-intercept, not from the origin, from the y-intercept, we're going to go down 1, 2, and then the x change is a positive 3, so we're going to go right 1, 2, 3. There's our new point. Okay? That's one way to do it. Another way to look at it would have been to say this is the same thing as 2 over negative 3. Think about that for a second, right? Negative 2/3, that negative has to go either in the top or the bottom. Okay, it can't go in both, because if you have a negative on top and bottom, it would come out to be a positive 2/3, right? So if we decide it's on the bottom, we have a positive change in y, positive 2, and x's change is now negative 3. So that means I could go up 2 and then left 1, 2, 3. Notice how that point is also on the same exact line. Okay, it does not matter which one of those you decide to use, where you put the negative. You'll still get the same thing. And sometimes it's useful to use one over the other. So I would recommend practicing doing both. Okay, let's get to the most complicated type of problem in this section, which is given 2 points, find the equation of the line in slope-intercept form, convert it to standard form. Okay, we're going to do all of that. So, when you're trying to find the equation of a line, given 2 points, you want to keep in mind that y equals mx plus b is a great place to start because you need to find two parts, m and b, and you have a formula for one of those. So usually our first step will be to find m. Find the slope. Remember, you have a slope formula. Okay, just think back. Y2 over y1 divided by x2 minus x1. Okay, now let me label these. First x, first y, second x, second y. Okay, so y2 is negative 3, y1 is negative 4, x2 is negative 3, x1 is negative 6. So we have double signs here, plus double signs here, that's a plus. So really that's negative 3 plus 4, which would be 1, and negative 3 plus 6, which is 3. So our m is 1/3. Okay, our second step will be to find b. Find b. Okay, well, remember y equals mx plus b. And keep in mind that you have 2 points here. Okay, when you plug in negative 3 for x, your y has to be negative 3. Or if you plug in negative 6 for x, your y has to be negative 4. Use that relationship to figure out what b is. Okay, y equals mx plus b. Let's just pick one. I'm going to pick this one here for no particular reason. Okay, y, negative 4, equals m, 1/3, times x, in this case, negative 6, plus b. Notice we only have one missing number there, right? One variable. Again, you could use this point here. You'll get exactly the same answer. Okay, if you don't believe me, try it out. Okay, so let's simplify this term. 1/3 times negative 6 is going to be negative, remember if you did 6 divided by 3, that's negative 2. So 1 times negative 2 is negative 2 plus b. Or if you prefer, you could have gotten negative 6 over 3 and then simplified that down to be negative 2. Either way. Okay, and then add 2 to both sides. Those will cancel. Negative 4 plus 2 is negative 2. So there we have an equation. Negative 2 equals b. So we found b. b is negative 2. Okay, so we have m and we have b. So finally, let me go ahead and write it down here. Y equals 1/3 x minus 2. Now remember, you have to keep the x and the y as part of the final equation because we only use a particular x and y value. This equation has to be true for an unlimited amount of x's and y's that are paired together, right? So the final equation should have x and y in it, not the numbers from the actual ordered pairs. Okay, finally, step 3, convert to standard form. To ax plus by equals c. Now remember, 2 things about standard form. First of all, there are no fractions, okay? No fractions, no decimals, nothing like that. Second of all, you have the x term first, the y term on one side, added together, and then you have the constant term on the other. So we have a few things we need to do here. The first thing I recommend that we do, though, is we get rid of the fraction. Okay, so here's a trick. Anytime you want to get rid of a fraction in the middle of an equation, okay, multiply everything by the denominator. If you have more than one fraction, multiply by the common denominator. Okay, so I multiply all 3 terms here times 3. I'm multiplying the terms individually by 3. 3 times y is 3y. 3 times 1/3, well, the 3's would cancel, leaving me with 1x. And 3 times 2 is 6. Now I need to have this x term on the left side, not on the right side, so I'm going to subtract x from both sides. And I'll just be careful to arrange my terms in the order that is here. X first, then y, then constant. So that'll be negative x, that's a positive 3y, and that all equals negative 6. So there it is in standard form. Okay, so yeah, that'll do it. So y equals mx plus b, slope-intercept form, is y equals 1/3 x minus 2. That exact same equation, just rearranged, is negative x plus 3y equals negative 6. If you plug in these x values, or you plug in these or you plug in this pair of x and y into either equation, or if you plug in this other pair, x and y, into either equation, you will get a true equation either way. Okay, that was complicated. Let's get to a few more. Okay, now these are definitely different. You'll see why in just a second. Okay, so we're going to find the equation of the line in slope-intercept form. That passes through the given points, and then we're going to convert to standard form. Okay, that's the instructions. You'll see how this is going to deviate from what we just did. So the first step we know is to find m. All right, if I used my slope formula, that would give me 4 minus 4, right? y2 minus y1, and then our x1, x2. So 3 minus negative 5 on the bottom. Double signs, we'll add them together. 4 minus 4 is 0. 3 plus 5 is 8. 0 divided by 8 is 0. Our slope is 0. Let's find b. Okay, well, keep in mind y equals mx plus b, so let's plug in one of these points. Let's go with 3 comma 4. So whenever y is 4, x is 3. 4 equals m0, x is 3 plus b. We already talked about it. Whenever you have 0 times a term, it cancels out. So you end up with 4 equals b. So we found b. b is 4. So if I go back and I plug it in, y equals 0x plus b, well, 0x plus 4, this whole term is going to cancel out every time because it's a 0 attached to it, right? So this is just y equals 4. This is a special case, okay? Y equals 4 is the equation. We can't rearrange that to put it in any other form. It kind of is in standard form already. What does that graph look like, though? Okay, let's plot it. Negative 5, 4, and 3, 4. Okay, negative 5, 1, 2, 3, 4, 5, and then 4 is here. And then 3 comma 4, right? Yeah, 3 comma 4. 1, 2, 3, 4. Okay, here's our special line right here, if I can draw it decently. Okay, it is a horizontal line. Okay, so that's what makes this a special case. That's why the equation is weird. It's like it's saying y is equal to 4. No matter what x value is, there's no x in the equation, so no matter what x value you can pick, the y will be 4. Well, that makes sense. That means we have a horizontal line because the y value is always, always, always 4 for every single point on a horizontal line, right? Okay, so the slope is also 0 because the line is perfectly flat. If I draw it decently, right? It's a perfectly flat line. There's no steepness to it. Okay, so keep that in mind. Let's do this next one right here. You may notice what's going on, or what's going to happen here. All right, let's say we have, again, our first x, our first y, our second x, and our second y. If I try to find m, I would have to do y2 minus y1 over x2 minus x1. Subtract a negative is plus, subtract a negative is plus. We end up with 5 plus 4, which is 9, over negative 2 plus 2, which is 0. Okay, we can't divide by 0. If you try that in the calculator, you get an error message. Okay, the common mistake people will make is say that it's undefined, or they'll say that it's 0, but that's not true. The answer is undefined. In other words, we don't have a good definition of something divided by 0. If you divide by 0, if you say that is actually equal to a number, then all our other rules are going to start breaking down. Okay, we cannot allow division by 0. Otherwise, math doesn't work anymore. Okay, so then what? What do we do with this? We can't plug in an undefined into our equation. All right, so that's where we're going to steal from what we just did over here. We recognize that y value repeated itself. Okay, and so we ended up with the equation y equals 4. The y value is 4 for all the points. Over here, the x value is negative 2 for both points. So our equation is just x equals negative 2. Okay, that's even worse than y equals 4. X equals negative 2. What that is saying is that x is negative 2, y is negative 4 down here, and then negative 2 comma 5 is going to be up here. You'll see that we have a vertical line. So the slope is undefined because if you're looking at that horribly drawn vertical line there, you'll realize that you can't even describe the steepness of this line because it's not even, like, you can't walk that, right? You can walk on a flat line right here if you're a little person. If you tried to walk this thing, you're falling, right? So the slope is undefined. It doesn't make sense in this context. It's like saying, how steep is this wall? It's a wall, right? Okay, so it's undefined. The slope is undefined. The equation is x equals negative 2. Let me go ahead and box that in as well to show that's important. This is a vertical line. All right, so we have horizontal line whenever the y value stays the same. Whenever the x value is what stays the same, we have a vertical line. Okay, let's summarize that in a little table here. Here's our special cases. If you have a repeated y value, the equation is going to be y equals whatever that value is. The slope will be 0, and you will be dealing with a horizontal line. If you have a repeated x value, then you're dealing with an equation x equals whatever that repeated x value is. The slope is undefined, and you're dealing with a vertical line. Okay, so let's put that to use real quick on these two problems. So let's find the equation, the slope, and the type of line. Negative 1 comma 5 and negative 4 comma 5, the y repeated. There we go. And so y equals 5 is my equation. The slope is 0. And we're dealing with a horizontal line. If I drew it out, it would be a horizontal line. 3, negative 4, and 3, 1, we have a repeated x value. X equals 3. The slope here is undefined. Okay, it doesn't make sense to describe the slope of a straight vertical line, the slope of a wall, right? And it is a vertical line. All right, and so that would be section 3.2, two variable equations.